1.2 billion kilometers from home. A world wrapped in orange mist waits in the dark. Beneath its clouds, rivers, lakes, and rain. But not of water, of liquid methane. A chemistry unlike anything on Earth. This is the story of humanity's boldest flight beyond Earth. Not a rover, not an orbiter, a dragonfly, built to fly. 8 rotors, 1 mission. To search for the chemistry of life itself. Titan has haunted scientists since Voyager first glimpsed it, decades ago. In 2005, the Huygens probe touched its surface and raised more questions than answers. An atmosphere thicker than Earth's. An ocean of water hidden below the ice. Titan, they realized, might be the closest thing to an early Earth we will ever find. To explore it, engineers designed something unprecedented. A nuclear-powered drone the size of a small car. Its heart, a radioisotope generator, turning heat into power for years, not hours.
Its instruments, mass spectrometers, seismometers, cameras built to read Titan's chemistry like a book.
Titan's thick atmosphere and low gravity make flight easier here than on Earth. Four times denser air, 1/7 the gravity. A flyer's paradise. Instead of one landing site, Dragonfly will leapfrog across dozens, covering more ground than any rover ever could. Every part tested for cold beyond imagination. 179 degrees below zero. Even its legs double as tools, drilling samples from the ground it stands on. A decade of design. Billions of dollars. One singular goal.
To ask, could life, or its earliest ingredients, exist somewhere beyond Earth?
Titan's surface is rich with organic molecules, the building blocks of life as we know it. All that's missing, perhaps, is energy and time. By 2027, the spacecraft was ready. Humanity's most ambitious drone, sealed for launch. Its journey to another world was about to begin.
T-minus 10 seconds and counting. Ignition.
And liftoff. Humanity reaches once more for another world. Within minutes, it leaves Earth's atmosphere behind, forever. Alone now, the spacecraft begins its long fall through the solar system. Behind it, home becomes a single point of light. The journey to Saturn is not a straight line. It is a careful dance of gravity. For years, Dragonfly will drift in silence. A lone machine crossing the dark. Each flyby borrows momentum, bending the path towards Saturn's distant rings. On Earth, teams wait, watch, recalibrate. Years become the price of discovery. Every system tested again and again. 500 million kilometers from repair. Every system tested again and again. 500 million kilometers from repair. Then, at last, Saturn appears. Its rings stretch wider than the distant distance between Earth and the Moon. And beside it, wrapped in orange haze, Titan waits. Titan's atmosphere burns hotter than expected, thick with unfamiliar chemistry. A parachute unfurls, buying precious seconds in the orange sky. Below, for the first time, dark dunes of frozen hydrocarbons come into view. This is the moment no rover has ever attempted. A powered flight to landing. 8 rotors fight Titan's dense air, guiding the craft gently downward. And then, contact. Humanity has landed on Titan. In a control room 1.2 billion kilometers away, decades of work become one triumphant moment. The first image arrives. An alien horizon, lit by distant sunlight filtered through haze. Dragonfly has arrived. Now, its true mission begins. Instruments awaken, ready to taste the chemistry of another world. Around it stretches Shangri-La, a vast sea of dark, organic-rich dunes. Somewhere beyond the horizon, methane rain quietly reshapes the land. Its first task? To drill, sample, and analyze the ground beneath it.
Within hours, the first data streams back. Complex organic molecules. More varied than predicted.
Scientists across the globe watch in real time as Titan reveals its secrets.
This data is incredible.
Days later, Dragonfly takes flight once more, its first true hop across Titan. Soaring above the dunes, it surveys terrain no camera has ever captured. Its destination? Selk Crater, a site where ice, organics, and ancient impact may have mixed. Here, scientists believe liquid water may once have pooled. This occurred shortly after impact. It was mixing with organic material. A brief, buried chemistry experiment. Millions of years in the making. Dragonfly lands, drills deeper, and listens for both chemistry and motion. Its seismometer detects faint tremors, whispers from Titan's hidden ocean below. Beneath 60 miles of ice, a global ocean of liquid water may still exist. A world that echoes what Earth may have looked like 4 billion years ago.
Every reading raises the same electrifying question. Are the ingredients here enough?
Season by season, Dragonfly continues its survey, patient, tireless, alone. It reaches the shoreline of Kraken Mare, a sea larger than the Caspian, made of liquid methane. Waves ripple here too, pulled not by water, but by wind, through an alien atmosphere. Back on Earth, researchers begin to piece together a picture decades in the making. Amino acid precursors, complex hydrocarbons, the chemical alphabet of life, all present, all real. No one claims to have found life, but they have found its ingredients waiting in the dark. Titan may not be alive, but it may show us how life begins. A frozen snapshot of the chemistry that once stirred on our own world, billions of years ago. What took Earth eons to hide beneath oceans and continents, Titan preserves in the cold. For a new generation, Titan becomes proof that exploration never truly ends. And already, scientists dream of what comes next. A return mission, perhaps even a submersible for Titan's hidden sea. We are, after all, a species defined by the need to ask, are we alone? Dragonfly cannot answer that question alone, but it brings us closer than ever before. A decade of dreaming, 7 years of traveling, a lifetime of wondering, all distilled into one small machine, alone on an alien shore. And in its reflection, a mirror of everything we have ever hoped to find out there. The mission continues. Every flight, every sample, every signal, another piece of the story.
Systems are nominal, but look here. This trajectory is unlike anything we have seen.
It means we are finally crossing the threshold. On Earth, a new generation of scientists is already asking, what world? Titan's day lasts 16 Earth days. Its year, nearly 30 of ours. But patience has never been humanity's weakness, when the reward is understanding. So Dragonfly rises again, chasing answers across a world built from the raw materials of life. Somewhere, on a small blue world 1 billion kilometers away, we watch and wait. Because the question of whether we are alone in the universe has never really been about them. It has always been about us, and how far we're willing to fly to find out.